In this video I want to show actually how to operate the machine. I haven't seen this on any YouTube video that I've watched. They show programming and things like that, maybe even setup stuff, but they don't really show how to operate the machine itself. Like, what do you know, when you get your tools all set up, what do you do when you actually start the program? And this is what I want to show, because I've noticed that people have these crashes. They crash into things, and this can be avoided if you use a certain procedures and you look at the displays on your control. And like I said, I've never seen this in a video before. And what we're going to do is we're going to start working on this these anvils that I was going to give away for 50,000 subscribers, which I haven't got back to this project, so I've gone beyond 50,000. But anyway, I wanted to get back on it, and I have some time here at the shop, and I wanted to show a certain thing in this video. Not so much machine work, but we're going to look at actually machining these pockets in this piece of material that I'm going to use to fixture the anvils to the forging that I've already prepped on a previous video to go on this. And I'm going to run this operation here you're watching right here, and it only takes one tool, so it's no big deal as far as the machine work or the setup or anything like that. But I'm going to show how when I run a tool for the first time, what I do and how I watch the displays on the control and various procedures I do. And there's different variations of what I'm going to show here, but basically it's the same. I'm not sure what controls that use like Mach 3 or the Tormach machines display on their monitors, but every industrial type control that I've ever run shows these displays, and I want to show how you use them to prevent crashes that you probably only get a crash actually approaching or moving away from the material or in your tool change areas, that really you can run into the stock because you had an offset wrong, or fixture offset, or tool offset, or something like that, or you made a manual edit in the program possibly in those areas, and because you don't have a proven post processor or something, and you could run into the material, or you left out some codes or something like that. And you can detect these things and prevent them by watching the displays on the control and what it intends to do and where it intends to move to. And like I say, I've never seen anybody make a video, I should say, on this subject, and I thought it might be a good thing to show, and might be some help to some people. So this is what we're going to do. Like I say, just machine these two pockets and this notch in this piece of material to prepare it for the rest of this, which I have to still machine, of course, in this block of aluminum to mount on the pallet, and then to mount the forging to eat out this material around the anvils on this side, and then I'm going to flip it around and cut these slots in here, and then I can just saw this apart or plasma cut it or something to separate the three pieces of stock from this, because I don't have a bandsaw big enough to do this. You know, it might be nice if you could drill and bandsaw this out maybe, but you've got to remove the material anyway, and I figured this would be the easiest way for me. It's not necessarily the best way, but just the way I can do it. So let's get to the machine part of this. I've got the setup made, and we'll see what I do to run in a tool, I should say, for the first time. Here's the setup we got going in the machine. You can see the parts just clamped down on these 246 blocks, and I've set the part 0 as centered in the stock here, in the X and the Y, as you may have noticed on the CAM software when I ran the simulation, and the Z is set 0 is set on this face that I've skimmed with the face mill. I've also skimmed the other side of the stock on this side, just to get two parallel sides, so that when I do the subsequent operations, I've got two sides that are parallel to each other. It's not really necessary for this particular setup, so I'll run it back to the B0 here that I'm using, which is of course parallel to that face. Okay, so that's our setup as far as the part goes. But even still, you could detect an error in that if you do what I'm going to show you here with the actual displays on the control. So on the Mitsubishi control, there's a screen like this. The actual position screen, if I go here and select position, looks like this. And you could run the machine from this display, but I don't really care for that one. I go for the one with the program. They call it the program display here, which shows me my program. This isn't the program we're running, that's an MDI. I'll put it in the memory mode. Now this is the actual program we're going to run. You can see it only has one tool. It's a 5/8 4-flute end mill. And the purpose of this is not to show anything about programming or anything, but it's to show how to run a tool for the first time. Although this tool has already had its offset set and I know it's correct, I'll show you the procedure just so you'll know and see how you can avoid running into the material because you don't know where the tool is going. And there's certain displays on every control that I've run that show you this information. And if you use the feed hold button and single block button in certain ways, you can avoid crashing into the material if you had something set wrong. And one of the most important displays to look at is what they call the distance to go display. So on this display, on this control, it's Meldus control, Mitsubishi Meldus. They have this window and you can see the G54, which is the default work offset, and the distance to go machine, and these positions, the program and the other position displays. But this one, this distance to go display, and what they call the C modal, which is usually called the command screen on most controls, but they call it the C modal display, has some information here that is very useful, because you can see the actual codes the machine has active right now. And these are really is showing you the default values because it's not actually running a program. And this is the codes this control defaults to, like a G54 fixture offset, and the various, G1, G17 is the plane of compensation, and G90 is an absolute mode, and so on. These are just the default values that it defaults to. And these change as the machine is running, and you can see this. And between this display, this distance to go display, and this display here, you can tell what the machine is doing and particularly with the distance to go display, where it intends to move to reach the next, what would I call, block or segment in the program. So let's start the program, and we'll see how I actually use the controls on the machine as far as these buttons and overrides and feed hold and single block and things like that, and run the tool up and do it in a safe manner to where you know exactly where that tool is going, so you don't actually just push cycle start and hope and pray that you can stop it in time before it hits the material if something is wrong. Here we go. I'm going to hand hold the camera because I've got to change the viewpoint a lot, and I really just can't mount it down on something and show you what needs to be shown here. So we're at the top of the program. Let's go to the display here. I'm going to put it in memory mode, hit reset. So now we're at the top of the program here. And this is just the one tool I have in the program, so we're going to be at the top to start here, but you might be restarting a tool and you might not be at the top of the program. Doesn't matter, it's the same principles apply. And we're going to push cycle start here. And this is just what my post processor does. It moves the palette out of the way. It's not necessary for this. I'm going to push feed hold in the middle of the tool change. On this machine, not all machines do this, it'll stop right after the tool change if you push feed hold. Some machines, this interrupts the tool change, so you can't do it that way. But this one, it's really nice because it does that. So now everything's stopped, and and we can kind of look and verify that the right tool's in the spindle, and we can continue on. So I'm going to push start here, but before I do, I'm going to set my rapid rate down. In fact, let me discuss a little bit about these controls on, you know, on this control and some machines, and the different ways that the controls work. This control is an older control, and it actually has knobs that you can feel the detents on, and you know, you can actually be looking over here at something in the machine, and you can put your hand on this knob, one of these knobs, and you know this one's the rapid and this is the feed rate, and you can override them without actually looking at them. This is an important feature that all controls should do it this way. Now, I could show you, for instance, let's go over here and look at this control that I have on my lathe, on the Mazotrol, on the Integrex, and you see the way they've made these buttons. And these overrides are like keys, these like these soft, or I don't know what they call these flush buttons, and you can't really feel or know where you're at without looking at it. You know, oftentimes I rest my hand on these keys, these buttons here, and then I can kind of do this, and I can kind of know where I'm at. But this, if there's any machine tool builders watching this video, this is a bad way to make a control. I'm sorry, I don't care for this at all. They've still retained the axis manual jog knob here, but other than that, this is not the best way to do it. And in fact, if you look at the newer Mazotrol, they've actually gone back to that. All right. Some people must have complained or something, and they've this is another smaller Integrex machine with a newer Mazotrol control, the Matrix control, and they've actually gone back to the knobs, away from those flush keys for this. So then maybe they learned their lesson on that. See, here's a Fanuc control, and the older Fanuc controls are the way my Mitsubishi control is on my horizontal, and they have knobs for all this with detents, and you can feel what you're doing. This is they even have a knob to control whether it's in the memory or MDI mode and everything on these older Fanuc controls. This is the proper way to do it on a control, in my opinion. I don't like the way they do those newer controls. Like on the Haas's, they're all those flush buttons, and you can't feel or do anything without actually looking at the control. I don't like that system. So anyway, back to what we're doing here. Now, we made the tool change, and the first thing we're going to do is set the rapid down. I'm going to set it to 25%. If you were really had to be critical, you could set it to 1% on this. At 0, the machine won't go anywhere in rapid. But I'm going to set this at 25%, and I'm going to push the start button. And the machine's going to move slowly down towards the work. And then I'm going to let it come down fairly close, and I'm going to push the feed hold button. Right now the feed hold is enabled, so nothing's moving anymore. And I'm going to look over here at the display and the distance to go display, and it says I'm going to go 2.5659 inches in Z to reach the end of my move, which says 1 inch on the program. So the first thing I'm going to do, and I usually do this as the machine's coming down, I put it in single block, so that if for some reason I missed the feed hold button in the wrong place or something, it would stop at least on that first move, because that's what single block does. It's going to run each line in the program separately for a separate cycle start. So everything looks like it could make it, but if you were really wanting to be careful, I usually don't do this, but you can do this, and you can look at this screen and you can see various things here. You can see that the fixture offset that's been selected is G54, which is what we're using. The tool is 58. You know, we can see up here on this display it's 58 as well. And this is the length of the offset of that tool. And on this machine or control, the way the offset page works, I could go back to it here and show you. Tool, if I go to the tool and offset, and we're using 58, you can see that value is the same as what you saw over there. But you see how this offset page looks on this control. It's all just a bunch of offsets. There's no separate offset like with wear values and everything like some controls have. You know, they'll have the tool numbers here, and they'll have, you know, the height offset and the diameter and the wear values and so on. This control doesn't have an offset page like that. So what I do is I use the first 100. It only has 80 tools in the machine, but I use the first 100 offsets for the length offset, and then I use the next 100 offsets for the height offset. So I mean for the diameter offset, which actually this machine uses radius instead of diameter, but that's the way it works for cutter compensation if you're using cutter compensation. So 158, as you saw earlier, was set to this value of 0.3115. So if we go back to this C modal page, you can see it right here, the two values. So you can see that here. You don't have to go back to the offset page. You can see that. Now, this tool is later using cutter comp. Right now, the cutter comp is set to G40, which is no compensation, but this will change when it starts that. But you can see the G43 line and all that right here too. So that's another display, and these numbers will change depending on what commands are called in the program as it happens. So that's very important and can tell you a lot if you need it. You know, like what is your plane of compensation for tool comp? You know, that G17 is X and Y, but if it was different, it would change this code here. Right now G80 is active, so that's canceling all drilling cycles and boring cycles and things like that on the control. So anyway, that's what this display can show you if you need it. So we're going to go back to the program display. We're going to say, okay, we're going to go down 2.565 inches. So we're going to look over here, and we're going to see that, yeah, we could go down 2.5 inches and not hit anything. And we've got the control into single block. So we're going to push start. See if I can position this. And it's going to come down to that 1 inch above the part, which is where it's setting right now, 1 inch. And we commanded it to go to 1 inch. So you can take something, the reason I do that is I can use like a 1, 2, 3 block now, and I can go back in here and I can just kind of compare that. And you can see small offset errors by doing this. You know, you can tell, you know, 10 or 20 thousandths of an error even by doing this if you needed to. Everything looks good. So we could probably run from here, because I know, because you saw the simulation and everything was good in the simulation, and so it'd probably be fine. But if you wanted to be even more careful, you could set these knobs down to 0 on the rapid and the feed, and because you're in single block, it's not going to actually move. Nothing on the machine is going to actually move. Well, the next commands in the program are actually for to turn the spindle on. Well, this is to call the spindle speed, and then to turn it on, and then to turn the coolant on, and then a dwell of 2.5 seconds. Now, I've got the coolant overridden with this button here, so the coolant isn't going to actually come on. But if I push cycle start right here, okay, it read the spindle speed here, and then it started the spindle. So now the spindle is turning at 4,000 RPM, and then the next command is the coolant command, which I have overridden with this button here right now. And then we got a dwell. You see the dwell counting off. Okay, so now the next move is actually going to be a move the machine would want to make, but because I have the knob set to 0, nothing is going to happen. And I also have it in single block, so I know it's not going to try to go further, even though it couldn't with these knobs to 0. and I can push cycle start safely here, and then I can look at my distance to go display, and I can see that the distance to go is 980 thousandths. Well, we just held a 1-inch gauge block up there, and we know it can do that, so I could let it do that. So right now it's wanting to do it, but because I have this overridden, it can't do it. And you notice, like before I described, it gives me this operational error because I have the rapid to set to 0. Now I'm gonna bump the feed rate up, but still nothing is happening. But I have to have this off of 0 in order for the machine to move as well as this off of 0. So now I'm gonna bump this rapid up, and you'll see that it moved down to the 20 thousandths in Z that the program commands. Now let me see. I'm going to try to do this without coolant, but the next move is actually a helical move. It's roughing out this pocket. So I'm gonna set the rapid down to 0. I'm gonna set the feed rate down to 0, and I'm gonna push cycle start. Now remember, nothing's gonna move now because the feed rates and rapid are set to 0. But now, and it's giving me this operation error message because I got my knobs on 0, but I can actually, let me see if I can do this. I can bump this feed rate up, and you see it's coming down into the part. It's making that first circle of the helix right now, and it stopped because I have it in single block. And it's going to want to continue that down. Now the feed rate is 32 inches per minute. So actually we should be able to see that on our feed here. Right here, see the feed rate? It's 32 inches per minute. The spindle is 4,000 RPM, and so on. Now if we had, it's not using cutter comp to do this roughing, but if it was, we would see if it was left, it'd be G41 here. If it was right, it'd be G42. So this thing can tell you, you know, a lot of things. If you were not commanding cutter comp and you needed it, and you're going to be cutting into the part way too much, this would show you. And if you are, you can see the value it's going to move by this radius value on this control. That's right here, the D value. So this is the way that I run a tool in for the first time if I'm not sure of it. And it's pretty much could be a good thing to do it, you know, every time you run the program for the first time, just to make sure everything is functioning properly, so you don't have these accidents and crashes that people have just by pushing cycle start. And even if they're going to do this and not do this, they should push start and sit here right on the feed hold button ready to stop it. But I even see a lot of people just push feed, you know, cycle start, and then they just kind of turn away from the machine. But even if I have a proven program, I don't do that. I push start, and I always watch the tool come down to the work, at least the first tool, just to make sure everything is correct. So let's look at this. See how it changed to G41 right here? Okay, well that's this little machining operation, just to cut these pockets out. Now I'm going to stand this thing up and drill these holes and cut those bosses to go into the T-slots here, so we can start the machining on the anvil pieces over here. So that's just a small explanation of you know, how to use the control, the switches and buttons and knobs and whatever to safely run in tools that you're not sure of, or start a first program that's never been run. So thanks for watching.